Greetings, my name is Tim Martin, and I'm here to offer the first video in a series of 30 videos that present a tutorial introduction to SQL. Each video is based upon a chapter from the free SQL book written by yours truly. Now, this is a substantial SQL textbook, well over 900 pages. Therefore, this series of videos offers a substantial introduction to SQL. Effectively, it's an entire course on SQL. This first video is directed to SQL rookies, folks who have little or no exposure to SQL at all. It presents a high-level introduction. We begin at the very beginning. An introduction to SQL and relational databases such as DB2, Oracle, SQL Server, MYSQL, and others. Now, I'd like to take a moment to thank you for choosing to watch this video. I am very well aware that there are many other SQL videos on the web. Thank you again. Well, let's go to work. This is video 0. There are 30 other videos following this. This is a getting started video. It's very, very important for rookies. This video corresponds to the free SQL book, which is a tutorial introduction to SQL. It's available at the specified website, www.freesqlbook.com. I will make some preliminary comments over the next 5-10 minutes. These are directed to experienced SQL users. If you're a rookie, just sit back and listen or fall asleep. Make certain you wake up when I start Section A. Section A will say a little bit about Relational Database Management Systems, abbreviated RDBMS, a little bit about what SQL is, and then we give you some concrete examples by previewing some sample queries that we'll see in the following video. Then we say a few words about hands-on SQL, not much, but it can get you started if you do not currently have access to some relational database management system. Let me deal with pronunciation. The proper pronunciation for SQL is just that, 3 letters, SQL. Stands for Structured Query Language. You might hear me and others refer to the language as SQL. Refer to it as SQL. I will do that frequently, as will other folks. That's an old name for SQL. Bottom line is, we're talking about the same animal. Don't let the difference in pronunciation disturb you. Okay, why do you want to learn SQL? I'm going to give you a pragmatic answer now, and I'll give you a more formal answer later on in the videos. The IEEE is a professional, highly regarded organization for electrical and electronic engineers. Within that organization, they have a subgroup called a Computer Society. Now, they publish research articles, scholarly articles. They also publish a magazine, which is not research, but just commentary on the state of the art. That name of that magazine is the IEEE Spectrum. And recently they had an article, and you're looking at the title of it here, the top programming languages in 2023. Python comes in first, but SQL gets special attention. All right. They also talk about some old programming languages, but we'll ignore that. When they take a look at jobs specifically, they say that SQL shines at number 1, top of the list. Now, they make note that you're not going to get a job if you only know SQL. All right? You're going to have to know SQL plus some other programming language. Within that context, they make a rather dramatic statement that employers love. Those are strong words for a techie article. Love, love, love seeing SQL skills in tandem with other languages such as Java. Now, from a pragmatic point of view, for many of you, this is good news. A more formal justification for the language will come later on. Let me say a few words to the experienced SQL users. You might want to skip many or most of the chapters or the videos that appear in this series of videos. I want you to take a look at the table of contents, which is on the following page, and perhaps even hit the pause button and look closely at some of the topics. It will tell you what topics are covered in these videos and indirectly imply what is not covered. I'll make that explicit in a bit. Then, if you've got enough experience, you can hop directly to the chapter of interest. Here's the table of contents. Part 1 introduces the select statement, which is used to retrieve data from tables in a relational database. Video-0 is this video, and in the following video, we get serious about the select statement, okay? If you take a look at the topics through the first 2 parts of the book, the first 11 chapters, I bring to your attention that these chapters, the sample queries in the chapters, only address one table. The from clause references a single table. I do that for good reason, which I'll explain later on. 9 of these chapters will address a table called preserve, which just has 14 rows which describe the nature preserves that we're interested in, and we will see that in a few minutes. Now, if you're an application developer, you would be interested in Part 3, SQL's data definition and data manipulation commands. How do you create tables and how do you put data in those tables, for example? For rookies, you can skip this Part 3 without any loss of continuity. The following part gets into join operations. How do we take 2 or more tables and merge the data from those tables together such that the result is in a single table? And that will generally apply in the following 2 parts of the book, and then there are some special topics we'll talk about at the end. Now, rookies have no idea what I just showed you on this page and the last page, and that's quite all right. Let me say a word about the target audience. I'm going to break the people who are viewing this set of videos and reading the book along with it into the category of super users and application developers. Now, a super user is frequently a business expert. They can be an accountant, financial person, engineer, data scientist, what have you. These people do not work in the IT department. They work in some business department, all right? And they want to do it themselves. They want to do their own SQL. They do not want to have to call up IT department, ask them to do something for them, and then wait. They want to do it now. A second group are the application developers who do work in the IT department. Now, these people are techies. When you say application developer, sometimes it just means a computer programmer. This person is writing programs for a system that has already been designed. So this is a narrow definition of an application developer. Sometimes application developers, in addition to being programmers, would be systems analysts and designers. They build the whole system from scratch. In both cases, the programmer and the analyst designer are part of this target audience. Now, if you're a rookie, That means someday you want to be a super user. Maybe you're a student right now majoring in business administration, okay? Or if you're going to plan on being an application developer, you might be studying in the computer science department. Now, let me say a word about these folks. Let me say a word about the super user. The super user, this smiley face here, sits at a front-end tool, and I'll say a word about the front-end tool. And sometimes, maybe not always, they want to type some SQL. The front-end tool sends that SQ down to the database management system, interprets the SQL, and goes out to the database, which we'll assume is on a disk. Doesn't have to be, can be any direct access storage device. We'll assume it's on a disk for now. The data is passed to the database management system, which sends it back to the front-end tool so the user, the super user, can look at it. This front-end tool is typically very friendly. It allows the user to point and click their way to happiness and get what they want. Why? Because the tool generates the SQL for the user and sends it down to the database management system for them. If that's indeed the case, why learn SQL? Well, there's a couple of reasons. One, the tool has its limits. When we get into complex queries, if you're using a tool, it's a lot of pointing and clicking, and we've all had the feeling of some uncertainty after we've done a lot of pointing and clicking and asking, is the tool really doing what we want to do? In that circumstance, the tool generates the code, but you, the super user, might want to look at that code before it's sent down to the database system. And if you look at it, you say, there's something wrong here. I think I will change it and fix it so it does what I want it to do. Sometimes the tool is not robust enough to satisfy the super user's query objective, and that's why super users will be watching a videotape like this. When we get to the application developer, one more word. Let me go back here. One more word. Let me say a word about architecture, all right? The figure you're looking at here, with the front-end tool, the database management system, the database, this could all exist on your personal computer. You will have somehow downloaded the front-end tool and the database engine that will store data on your disk on your personal computer. Now, see this bold line I have between the front-end tool and the database management system? That line could be a communications network. It could be a local area network inside a small school system, or it could be that the front-end tool is on the desk of some user at home who is telecommunicating to a company, maybe via the internet, 1,000 miles away. For our purposes, it doesn't make any difference right now. And in fact, I kind of prefer everybody having all their software on their own personal computer. Do you need to do that for this particular course? No, but it has some advantages, which I'll describe later on. Now we have an application developer. And again, all of these components can be on your personal computer. The new component here is an application program. So the front-end tool, I'll say a word about that front-end tool in a moment, allows the application developer to write an application program. Again, in Java, C++, PHP, whatever, and plug SQL inside that program. That's called embedded SQL. Then the program is sent down to the system. The system executes the program, including the embedded SQL. Now, this is not necessarily a friendly front-end tool designed for unsophisticated users. It's sometimes called an integrated development environment. It allows the user to code SQL and do the same things that the super user does. But it goes a step further. It facilitates the coding of embedded SQL. And if you are a database analyst designer, if you're going to do a design, it can help you there. And if you are a database administrator who is not a member of our target audience, I'll say a word about database administrators later on, but if you are a database administrator, you can use this tool. Within the context of this course, we make one thing very, very, very important. You cannot write embedded SQL unless you know how to code SQL in the first case. All right? It could take you a little while to learn all the SQL I'm going to present in this series of videos. But if you hang with me to the bitter end, you'll know a lot of SQL if you do the exercises which are presented in the book. Okay? By the way, there's an answer book along with the book itself on the website. Now, once you learn SQL, how long does it take you to learn to embed the SQL inside an application program? Well, probably about 2 hours. All right, that's about it. So the question is, if it's that short of a period of time for the basics, then why do I not intend to present it in this series of videos? Why did I not present it in the book? Here's an answer. It varies according to the language you're using, and it varies according to the particular database management system. So, if you learn to embed SQL in Python, it will be different than learning to embed the language inside PHP or inside Java. Furthermore, if you learn to embed the language inside Oracle, there will be differences when it comes time to embed the same SQL inside, say, MySQL. There's such a variety of programming languages and a variety of database management systems, which makes the embedding of SQL, which is not really difficult, very specific, and therefore I contend that if you know your SQL as presented in these videos, then you will not have much of a problem with the embedding of the SQL. All right, what's covered in this book and what's not covered? The videos in the book, they cover what I call core or vanilla interactive SQL. This is basic standard SQL. It's interactive in the sense that the user types the SQL, step 1, hits an execute button, step 2, and looks at the result, which is returned for step 3. This is for a relational database. I emphasize that because some non-relational database systems can also understand SQL, and we won't talk about that. The data we're going to see is structured. If you've ever seen records in a file, well, you're going to see here rows in a table. Pretty simple structure. We're going to see numbers and character strings and date time values. Nothing fancy at all. This is classic structured data. There are optional appendices, and probably 15% or so of this 900 plus page book relates to the appendices. Now, with great emphasis, these appendices are optional. Okay? They're not presented in these videos. But if you're going to get serious about SQL, then I encourage you to take a look at some of these videos. What are some of the topics what we're talking about? Well, what we want to do is write correct SQL. And then we'll hope it executes fast. So we will see that your focus will be on logical correctness. We'll have the system worry about efficiency. Now, how does the system do it fast? Well, that depends on what we call physical database design and query optimization, and some of the appendices talk about those topics. Now, let's assume the system doesn't exist yet and you are doing analysis and design for the new system. Then some of the appendices help you arrive at a conclusion of, hey, what tables should I create? And what columns should I put in those tables? And we talk about a database design methodology that can get you started to look at other references. Finally, there's a theory. This will probably be appealing to the math majors and the computer science majors, but actually the theory is interesting and it's simple, and I encourage you to take a look at that if you have the time. Now, one more time, these appendices are optional. If your goal is to get in, learn your SQL, and get out, you can skip the appendices. Now let's say what's not in the videos, okay? Well, we do not talk about embedded SQL for the reasons I just mentioned. It's pretty basic, takes you a couple hours to learn it, and there's too much variation across database management systems and programming languages. Furthermore, we will not talk about semi-structured or unstructured data. Let me make a comment. SQL is a very old language. Papers appeared on it in the late 1970s, and people were using it in the mid-1980s. IBM and Oracle had products in the marketplace by then using classic structured data. Over time, over the last 50 years, people said, well, maybe I want to take HTML and save it in my database. Maybe I want to save XML. Maybe I want to save a whole textbook, all right? Maybe I want to save an engineering drawing. All of these others kind of, let's just say, semi-structured data. There's now a way to put that inside a relational database and get at it using SQL. Furthermore, there's unstructured data. How do you store an audio or a video or a movie inside a relational database? Well, you can do that too. Really neat stuff, but you have to understand the core information which is presented in these videos before you jump into these advanced topics. Okay, that concludes my preliminary comments. If you're a rookie and you're totally confused, don't lose hope. Things get simpler starting now. Let's begin at the beginning. What's a relational database management system? We've highlighted relational here. What makes a relational database management system a relational system is that the data is stored in tables. A table is a pretty simple structure, and that may account for the popularity of relational databases and its associated language SQL. Here's an example, an academic database. Think of a small college. It'd probably have a student table, one row for each student, currently active student, let's say, we'll forget about history. One row for each course that's currently in the course catalog. One row for each faculty member who's currently teaching at the college. Pretty straightforward. Not shown here is going to be some relationship between student and course. How do we know what courses a student has taken or vice versa? How do we know what courses a faculty member is teaching, what faculty are advising, what students? That gets into relationships, more on that later on. There are some popular relational database management systems out there. DB2 started it all. This was IBM's product, okay? It was the product that had the first version of SQL in it. Then along came Oracle, then along came SQL Server. Oracle's owned by the Oracle Corporation. SQL Server is owned by Microsoft. These three commercial products are available for free. I'll say more about how you can get those if you want to. I have tested all the SQL statements you're going to see in this sequence of videos on Oracle, SQL, SQL Server, and DB2. I comment where there are differences, and there are not very many differences. There's also open source systems like MySQL and SQLite. Those are generally, well, they're all open source, so therefore they're free, and they're generally easier to install. More comments on that later on also. Let's take a look at an example of a table in a relational database. You're going to be working with this table a lot throughout the first two parts of the book, so become acquainted with it. This table is called Preserve. It stores rows about nature preserves, and these are real nature preserves which are maintained by the Nature Conservancy. There are 14 rows in this table. You will see that each preserve has a number, a name, it resides in some state, it has a certain size in acres, and has an admission fee. If you just take a look at a sequence of values there, you'll see that the states that have preserves are in Arizona, Montana, and Massachusetts. There's 14 of them shown here, but the Nature Conservancy has maintained more than 1,000 preserves throughout the United States and other countries. That's all we need to know right now. Let me put a plug in for the Nature Conservancy. It protects properties from development in most, probably all states. Like to say there's nothing wrong with development. We need houses to live in, apartments to live in, maybe a few shopping malls, and even a few golf courses. Some properties are just too beautiful or too ecologically significant to be turned into a shopping mall or a golf course. The Nature Conservancy attempts to purchase the development rights to such properties, and if they are successful, usually you and I can take a hike through such properties. Okay, enough of that. Now we're on to SQL. What's SQL? It's a language which is used within relational databases. It's how you talk to a relational database. Most, but not all statements, most statements reference a table. For example, where does a table come from? You're going to see the create table statement for that preserve table in a moment. But you also want to be able to insert rows into that table. You'll use an insert statement for that. You'll also want to be able to change the values in some rows. You'll use an update statement for that. You want to make some rows go away. You'll use a delete statement for that. And finally, the most popular statement is the select statement. This is the statement you will use to retrieve data from those rows. Very often, it's only the application developer who creates a table, and it's only the application developer who does insert, update, and deletes. However, super users very often only do select statements. Let me make a preliminary observation about SQL. It's easy. It's not a hard language to learn. However, knowing your data can be a challenge. And if you're just looking at rows and tables, usually it's pretty straightforward, but we will have to identify some subtle points, especially when it gets to the topic of multiple tables. The first 3 chapters, the first 3 videos after this current video all pertain to issues of knowing your data. That the know your data concepts will be presented within the context of sample queries. Then there's the logic, know your logic. This gets into more complex logical statements like statements that use and, or, and not to connect simple conditions into compound conditions. That topic will be addressed in Chapter 4. If you've done a lot with computer programs which had more complex queries involving and, or, and nots, you probably know everything you need to know that's in that Chapter 4. Let's take a closer look at this preserved table. We had a peek already. Let's look at some details. First of all, every column has a name. That's not a surprise. Preserved number, preserved name, the name of the state that the preserve is located in, the number of acres for its size, and an admission fee if it has any. Notice columns get names, rows do not get names. Now, every value in this preserved table is either a character string or a number. Pretty simple. Looks like preserved name and state are character strings. The others look like numbers. We can see that by merely eyeballing the table. But eyeballing has its limits. What about this preserved number? Okay? What about the preserved number? Is it a real number, or is it a character string that only contains digits? We do not know by eyeballing this table. We can't tell. What we need to learn, is the data type of each column. So let's tell you the data types for each of these columns. The preserved number is indeed a number. It's not a character string that looks like a number. It's a whole number. It's an integer. Acres is an integer, and fee is a decimal. All right. Now, it's clear if we look at the fee column that it has a decimal value. Maybe the acres column is decimal also, but we've only displayed the integer part of the decimal value. We don't know that yet until we see that acres is indeed an integer and the fee is indeed a decimal, and I assume that you know the difference between an integer and a decimal. Now, the state's a character string, but it's a char data type. That means it's a fixed length character string. And the pname column is a varchar data type, which means it's a variable length character string. And that's pretty much clear by observation, but we have to be careful. Let me just state that sometimes a fixed length character string looks like a variable length character string, and vice versa. And that can be slightly confusing. So we're going to have to tell you more in the future about the real difference between a fixed length versus a variable length character string. Where do these data types come from? They are specified inside a create table statement. Now make a note. Most of the time, super users never execute a create table statement. Application developers might not even execute it. Maybe this person called the database administrator executes the create table statement in a production environment, but maybe the application developer is allowed to execute create tables in a testing environment. Regardless, I think even rookies can understand this create table statement, even though they may never execute it. Now, if somebody executes it, you may or may not be able to find it. That's another story. So let's look at the example. This is where the table got its name, create table preserve. By the way, when you're looking at this create table statement, ignore parentheses and commas and all of that stuff. That'll be presented later on around chapter 14, I think. Each column gets a name, preserved number, pname, state, acres, etc. And this is where we see, if we look at for the PNO column, here's where we find out that it's an integer. When we see pname, we see it's a variable length character string. And here we find out, but it can't be longer than 25 characters. When we look at the state, we see it's a character string, but it's a fixed length character string. And every character string is exactly 2 characters long. The acres is an integer, and the fee is a decimal. And here we find out there are 5 digits in this decimal, with 2 places after a decimal point. So there's the names of the columns and the data types and the specific data types with respect to the links. Now, every column is designated as not null. What does that mean? It simply means when a person inserted rows into this table, they never omitted a value. If they did omit a value, they would get an error message. Every column must be specified. It must be known to the user. Only the first column is unique. What we're telling you now is something I didn't say a moment ago. Preserved numbers are unique. Now, you might think preserved names should be unique. And in this case, because the keyword unique is not specified after not null, then guess what? We could have duplicate preserved names, and you might challenge that particular policy. Likewise, we could have duplicate state values, duplicate acres values, duplicate fee values. Now, this create table statement creates an empty table. The table is there, but there's nothing in it. It's like an empty bucket. Subsequently, somebody will execute an insert statement, and this is an example. And insert statements are pretty simple also. Insert into the name of the table, preserve, the following values. This table has 5 columns, therefore 5 values come in. The preserved number is 3. The preserved name is a character string, so what you see is the value Dancing Prairie is enclosed by an apostrophe, not a quote. This is an apostrophe. The same thing with the code for the state of Montana, then numeric values for the acreage and a fee. There would be 13 other insert statements to create the preserved table that you've just seen. I want you to know your data. And at the simplest level, you're going to want to know the name of your table. And some of you might be working on a large system where there's hundreds of tables. But you probably won't be working with hundreds of tables. You'll be working with probably 2, 3, 4, 5 tables that pertain to your world. The table will have many columns. For each column, you'll want to know the name of the column. What's its data type? Not just whether it's a number, but you want to know whether it's an integer or a decimal. Why? We'll see later on. Are the values inside a particular column unique? Okay, only the preserved number, P&O, does that apply to. And are null values allowed? No, every value must be specified in our create table statement. Well, how do you find this out? Usually you got to read some documentation, but it's possible that that documentation is possibly obsolete. It may be the case after the table was created, the database administrator came along and added 2 new columns that you didn't know about. You can look at the create table statement, but that might be obsolete also. You're looking at the create table statement that was executed before the database administrator added new columns to it. The only way you can find out is ask the system. So you'll be working with some particular relational database system, and there's some way you can find out more about that later on. Next, we turn our attention to sample queries. All right? Sample queries are the heart and soul of this textbook and the following videos. 80% of what we're going to present to you illustrate sample queries for data retrieval. Here we're simply going to do a preview of those sample queries you will see in Chapter 1. We're going to skip a lot of details, go to the core concept without details, and invite you to ask yourself the following question. What's going on here? So if we say to you, display all data in the preserved table, here's the select statement that does it. Select, skip a space, then followed by a star or an asterisk. That will give you all the columns. There are 5 columns in Preserve. We see them all. From Preserve, so we're talking about the Preserve table, not some other tables that we will see as we progress through these videos. I bring to your attention there's no where clause. We will see the where clause in a moment. The absence of the where clause says give me all the rows. Star says all the columns. Absence of a where clause, give me all the rows, and there's the entire Preserve table. If you look at this, some questions might pop into your mind like, hey, this table is not sorted by any particular column. I will address that issue in Chapter 1. I just want to have you get a feel for what's going on here. Let's take a look at our sample query here. Second one. Display all rows where the fee value is equal to 3.00. Display all columns in these rows. We want to display all columns, so we say select star, again from the Preserve table. Where, and now we introduce the where clause, because we don't want all rows. We only want the rows where the fee column is equal to 3.00. If we look at the result, those are the few rows that have a fee of 3.00. Type of questions we'll address in the following chapter is, what happened if we just said 3 as an integer whole number as opposed to 3.00? What's the issues involved with that? Simple, but they need to be addressed. The next example shows a where clause, and it says where state is equal to a particular value. Notice I'm not talking about the sample query. You could read the select statement, select all the columns, there's the asterisk, from the Preserve table. I only want the row where the state column is equal to AZ. But notice the AZ is surrounded by apostrophes, not quotes. Forgive me, I will say quotes in the future. When we're talking about specifying character strings, we will see apostrophes. These are the 4 rows for the state column, which is AZ. Of course, that means you know that when we're looking for rows about nature preserves located in Arizona, there's a code called AZ, and by the way, that's in uppercase. One more comment. That state column is a fixed length character string. Are there any differences if we have a variable length character string? Well, let's go down to the next sample query. Display all information about the Ramsey Canyon Nature Preserve. You got to know that we're talking about the name of a preserve, and therefore you have to know you're searching the P-name column. And again, we see a character string surrounded by apostrophes, and that gets the 1 row which has the P-name value of Ramsey Canyon. All right. Notice the where clause for this variable length character string has the same basic syntax as the fixed length character string. And we make an observation. When you're dealing with character strings, whether they're fixed length or variable length, they're usually treated in the same manner. And they will be until we get to Chapter 6, and then we have to tell you about some subtleties. For this reason, we want you to be aware of whether a character string is fixed length or variable length when you're searching on it with the where clause. Again, we talk about that in the next Chapter 1. Sample query 1.4. For every row in Preserve, we want all the rows. That means there's not going to be a where clause. Display 3 columns, P-name, acres, and state. Here they are, P-name, acres, and state. You look at the result, it shows those 3 columns only and all the rows. What you do is specify the names of the column separated by commas, specify them in the left to right sequence that you want to display the columns. The next sample query does not teach anything new. Let's forget about the query objective and just look at the select statement. Select two columns, pname and acres. That's all you see here, pname, acres. From the preserve table, where the state is equal to AZ, and there are the rows for the Arizona preserves. All we've done is put together the concepts that were presented in sample queries 1 through 4 and take the same concept, same syntax, and put them together in this sample query 1.5. Again, there's more comments to be made in Chapter 5 when we get to it. So, sample queries are all pretty straightforward in terms of what you have to do. Looking at this example, you get to a certain page on your front-end tool. We'll say a bit about that in a moment. On that page, there'll be a box where you type in your select statement. After you type in your select statement, you push an execute button or a run button, not shown in this figure. And in the result window, up pops the result of the query. Let's talk a little bit about hands-on SQL, and this is just a little bit to get you started. Let's just assume you already have your front-end tool and your database system installed on your particular system, whether it's a client-server system or your own personal PC. When you fire up that front-end tool somehow, usually point and click on some icon on your computer, it'll bring up front-end tool, and you may or may not see a page that looks like what we see here. This is an unofficial term. I call it the SQL page. All right? It's a page where you are invited to type in SQL and look at a result. There will be other stuff on this page I'll show you in a moment. For the moment, your focus is to find this SQL page on your front-end tool. That'll be pretty easy, and once you do it, you just do the same thing over and over again. No big deal. That's going to vary from front-end tool to front-end tool. There will be a place for you to type your SQL. Another unofficial term, I just call this the SQL panel or the SQL window. There you go. You type in your select statement, find that button. That means run or execute. You hit that button, the select statement goes down a road, and back comes the result, and the result appears in what I'll call a result window or the result panel. Once you get the flow of that going, okay, and you get going with the SQL statements, that's what you're going to do over and over again. Type in a select statement maybe, hit the enter button, get an error message back. You forgot a comma. All right. Well, you just fix it, edit it, hit the enter button again. It goes off and you get a result. There are many different front-end tools. I'm going to show you an example of one front-end tool. This is the SQL page on a front-end tool called IBM Data Studio, which is a front-end tool that IBM encourages you to use if you are using its database, which is called DB2. You could use this front-end tool to access an Oracle database. You'd have to do some gymnastics first, but that's possible. The only thing I want to illustrate is that your SQL page will have a bunch of other stuff, all right? And for the moment, ignore all this other stuff, okay? There'll be a place where you can type in your SQL, observe the select statement in the middle, select pname, comma, acres, run preserve, where state equals AZ. You hit a button on this tool. Over on the right, there's a green circle with an arrow in it. That's the button you click on. Lo and behold, up comes the result window. And there they are. There's the result. The 4 rows showing the pname and acres values for the Arizona preserves. You'll get other stuff with this, like execution time. Now, Every page will be different if you're using the Oracle front-end tool or the SQL Server front-end tool or the MySQL front-end tool. They'll all be different, but they will all have a place to type SQL, a button to hit, click on, and a result area. And once you get flowing, the process of doing this will be very, very easy. Not a lot will inhibit your learning SQL. Okay. One more page, two more pages. If you're using DB2, the name of the front-end tool is Data Studio, as I just said. If you're using Oracle, they like you to use SQL Developer. If you're using SQL Server, Microsoft likes to have you use Visual Studio. If you're using MySQL, they have a front-end tool called a MySQL Workbench. As I said a moment ago, sometimes you could use SQL Developer, Oracle's front-end tool, to talk to the database engine, DB2, which is sold by IBM. We're not going to get involved with that architecture stuff. What you will have to do at some point, and you're not in a position to do this yet if you're a rookie, okay, is to install on your PC, if you want to, your database system and your front-end tool. I just want to have you get an idea of the layout. Those of you who are working at a school, perhaps, you may have a computer laboratory where this is already set up for you. Okay, finally, a word about the book. This book is really free, all right? As you watch the videos, everything I say is in the book. Therefore, I encourage you to sit back and just watch for concepts. Then you can go to the book. Everything that's important is written down. There will be some exercises. The answers are found in the answer book, which is also on the website. Okay, this is really free. No registration, no email requests, no cookies, none of that stuff. But I hope you like the book enough to cough up $5. It's optional, and send it directly, not through me, to the Nature Conservancy at this www.nature.org organization. There are other worthy environmental organizations, many of them. Two others that I send money to are the World Wildlife Organization and the Audubon Society. The only restrictions on the freeness of this book is that there is a copyright, whatever that means, okay? There's a copyright. And finally, sometimes a for-profit training organization used to pay me to use my notes when they taught their course. So what I'm saying is I don't want that money anymore. If you're a for-profit organization, instead of paying me, make a modest donation to one of the environmental corporations. And the details for this are on page 2. Actually, it's going to be pretty modest donation you'll have to make to these organizations. That concludes this video, except for the following page, which will direct you to the next video on this sequence.